Greetings of the day. This is our Edu Guide, and today we are going to do a chapter called Equilibrium from grade 11. It's a very important chapter, and it's a very important chapter from term 2. So let's begin. First, we're going to look at what's equilibrium. I'm going to draw a seesaw so we can understand what's equilibrium. Now, let's see. So we have the fulcrum here. Let's assume that there are two objects, one which is heavier than the other. So obviously in this situation, the seesaw is going to tilt to this side because there's a heavy object over here. There's a heavy object over here. Now let's take another situation where we have objects of same weight. Okay. Let me try drawing objects of same weight. So we have an object here. We have an object here. Let's assume that these were the same weight. Then there will not be any tilt seen in the seesaw. It will remain like this. It will remain straight. It will remain like this itself. There will not be any tilt to either this side or this side because the weight, the objects have equal weight. So this state is called equilibrium. So equilibrium can be said to be a balanced state. Okay, equilibrium can be said as a balanced state. Now, let's see how equilibrium can be applied to chemical reactions. Okay. So now we have this equation over here. Oops, my bad. Okay, now we have this equation over here. 2Na, sodium, plus chlorine gives a sodium chloride. Now, if you look at this equation, it goes in one direction. That is, sodium plus chlorine gives sodium chloride. We'll also look at the general equation of a reaction. That is A plus B. A plus B gives C plus. Let me type that. A plus B gives C plus D. That is, reactants give a product. Now, this process takes place only in one direction as an irreversible reaction. Now, we'll look at other reactions for comparison. Now, let's look at this reaction. Now, what's different here? So, in this reaction, we have nitrogen, hydrogen that reversibly gives us ammonia. Now, here you can see double-sided arrows, double-headed arrows. So this double-headed arrow basically means that the process is taking place in both directions. Now, what does that mean? So here now I said nitrogen and hydrogen gives ammonia. Now this ammonia, which is the product, can decompose to give us hydrogen and nitrogen. Then you can see that process is taking place in both directions. So this is called a reversible reaction. That is, once we get ammonia, we can also decompose it to get nitrogen and hydrogen. Now, what is forward and backward reaction in this chemical equation? So nitrogen plus hydrogen reversibly gives us ammonia. This is the forward reaction. And when ammonia gives us hydrogen and nitrogen, this is called the backward reaction. Okay, so when the reactants combine to form the product, it's a forward reaction. And when the product decomposes to form reactants, it's a backward reaction. Okay. Now let's move on. So this is an important concept. At equilibrium, the rate of forward reaction will be equal to the rate of backward reaction. This is a very important point. This one and this one, like all of them actually. So in a chemical reaction, chemical equilibrium is defined as a state at which there is no further change in concentration of reactants and products. The speed of forward and speed of backward reaction is the same. Now, basically when we have N2 plus CH2 reversibly gives 2NH3, the forward reaction, that is nitrogen plus hydrogen, gives ammonia. The rate of that reaction will be equal to ammonia decomposing to form nitrogen and hydrogen. Now let's understand the second point. To understand the second point, I will draw a jar. Okay. Assume that this is a jar. A jug actually, yeah, jug. And there is a leak over here. Okay, so now some water is being poured into this jug. There's already some water in the jug, and some water is being poured into the jug, and some water is leaking out. Okay, now let's assume that more water is being poured into the jug than that which is being leaked out. So obviously, what will happen to the level of water in the jug? It will increase because there is more water going into the jug than which is leaking out of the jug. So the level of water will increase. Now let's assume there is more water leaking out of the jug. Okay, let me draw more water leaking out of the jug than which is being poured into the jug. So obviously the level of water will start to decrease. Now let's assume the water that's being poured into the jug and the water that's being leaked out is the same. Okay, assume that it's the same. Now the level of the water in the jug will remain the same because the water that's being poured into the jug and leaking out are the same. So the level of water remains constant. This same concept can be applied to a chemical reaction. I will write the chemical reaction here again so that it can be understood. It reversibly gives let me draw the double-sided arrows. Okay, so in this reaction, now the forward reaction, that is N2 nitrogen plus hydrogen gives ammonia, remains the same. That is, let's apply to the jug. The water that is being poured into the jug remains the same. And ammonia decomposing into hydrogen and nitrogen remains the same. That is, the water leaking out remains the same. So likewise, the concentration of the products and the hydrogen, the concentration of the reactants will remain the same. The concentration of all the reactants and the products will remain the same. Speed of forward and speed of backward reaction is same at the state of equilibrium, as the rate of forward reaction is equal to the rate of backward reaction. Now let's go to the next slide. Okay, here we can see the graph concentration time graph of the reactants in the product. As we know, in a reaction, the reactants at the beginning would be more because the reactants are slowly converting to products. That is A plus B. We know A plus B gives C plus D, so this would be A plus B. So the reactants are slowly converting into products, and C plus D the products are increasing because the reactants are converting into the products and the products gone increasing. And here the reactants in a chemical reaction, the reactants combine to form products. So as the time increases, the reactants are forming more products. So the concentration of products increases, while the concentration of reactants decreases. At a certain stage, which is at equilibrium, the concentration of reactants and products will remain the same. So that's what is shown in this graph. Thank you. This was the first part of our chapter, equilibrium.